So we are picking up on notes about parallel lines. Parallel lines. Parallel does not have an N in it. And transversals. So you took notes before on the different angle relationships that are formed when you have parallel lines and transversals, or at least when you have lines, two lines, and then a transversal between them. So now we're going to talk about what's true when you have lines that are parallel and then a transversal that cuts in between them. So parallel lines, we designate them in figures not by just looking like they're parallel, because we can't really trust the image. They have to either tell us that they're parallel, so they have to tell us in words. So that you have to say, like, if this is line L and that's line M, then they need to say line L is parallel to line M, or they use the words parallel. Another thing that they do is, you know how when we had congruent segments, we would say that's congruent to that? Well, we have something sort of similar when it comes to parallel lines. It's not going to be a little tick mark. It's going to be an arrow. So it looks like this. So it might just be a single arrow, or it might be filled in. But whenever you have that little arrowhead, that means that those two lines, line L and line M, are parallel to one another. Okay, so let's say we have line L and line M, and we have transversal T cutting through them. We should hopefully remember from our notes the different angle relationships that are there. We have corresponding angles or alternate interior angles, vertical angles, and all that good stuff. So we're going to talk about what happens when we have parallel lines and transversals with these angle relationships. So if two lines are parallel and are cut by a transversal, then there's a lot of things that are true. We can say each pair of corresponding angles is congruent each pair of, not only are corresponding angles congruent, but we'll say alternate interior angles is congruent. Each pair of alternate exterior angles is congruent. So, and then always, this is just recalling from our previous unit, every pair of vertical angles is congruent. And that's just true for any vertical angles. So we've got three types of angle pairs that are always going to be, I'm sorry, four types, always that are going to be congruent. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior and vertical angles. They are all going to be congruent. Now, the rest of the angle relationships are going to be supplementary. So what that means is each pair of, and I'll list a bunch, each pair of consecutive interior angles is supplementary. Each pair of consecutive exterior angles is supplementary. And as always, each linear pair is supplementary, because that's just the definition of a linear pair. Okay, so just to reiterate that, each pair of consecutive interior angles are supplementary, consecutive exterior angles are supplementary, and then linear pairs are all supplementary, meaning they add to 180. So some angle pairs are congruent and some are supplementary. Notice we're not talking about right angles or anything like that. They're either supplementary or congruent. So let's get an example and then explore all of these linear pairs. So in this example, I'm going to have two lines, so please draw this. And we'll say this is line A and B. And I'm going to say that they are parallel, and I'm going to denote that by drawing these little arrows. Okay. So we're going to say A is parallel to B. And then we also know that because we drew these little arrows on the parallel lines. That's what shows that they're parallel. Whoopsies. Okay. And then let's draw a transversal on there. So this is transversal T. And we're going to label the angles. This is angle 1, 2, 3, and 4. Then 5, 6, 7, 8. Okay. I'm going to tell us that the measure of angle 1 is equal to 65 degrees. And then using just that one angle, we're going to be able to find the measures of all of the additional angles. So let's say I'm looking for the measure of angle 2, and so on. So let's just start with the measure of angle 2. Well, let's look at where they are. I have angle 1 and then angle 2. So here's angle 1. And I'm going to use different colors and also different double arcs or single arcs to designate the two. So if I drew for angle 1, since I drew a single green arc, any other congruent angles, I would also draw a single green arc. So since 1 and 3 are vertical, I'm just going to draw a single green arc to show that those two angles are vertical to each other, okay, or congruent. Now, measure of angle 2, let's look at that angle relationship. Well, angle 2 makes a linear pair. So that means that it's supplementary. So if 1 is 65, angle 2 is supplementary to that. So we're going to have to do 180 minus 65. And we get, let's see, 115. All right, let's look for the measure of angle 3 now. So I'm going to kind of box this off. The measure of angle 3. Well, let's talk about the relationship between what we know, measure of angle 1, and the measure of angle 3. Well, 1 and 3 are vertical angles. So that means that they're congruent. So if 1 is 65, then 3 is also going to be 65 degrees. And if you want, you can label in your picture 65, that's 65. And we already said that number 2, angle 2 measures 115. So we can always add that to our picture because that's going to help us with the next ones. So that was measure of angle 2 and measure of angle 3. How about the measure of angle 4? Well, we could figure this out a couple different ways. If we're talking about in terms of angle 1, 1 and 4 are a linear pair. So 1 and angle 4 make a linear pair. So that means that they are supplementary. So if 1 is 65, then 4 has to be 115. If we wanted to think in terms of angle 2, we could say, well, angle 2 and angle 4 are vertical, so they have to be congruent, so they're both 115. So that's those first ones. Let's look at finding the measure of angle 5 now. I'm going to get rid of this. So the measure of angle 5. So here's angle 5. right here. Um, let's look at 5, where 5 is in relation to angle 1. They are on the same side of the transversal. I like to highlight my transversal to really see it. There's the transversal T. Notice angle 1 and angle 5 are both to the left of the transversal. So that means that they're either going to be corresponding or consecutive. Consecutive. Okay. If they're corresponding, then that means they're in the same position. They're either both above the parallel lines or below the parallel lines. Angle 1 and angle 5 are both above each parallel line. They're in the same position. So that makes them corresponding angles. So angle 5 and angle 1 are corresponding. Which means they're congruent. So if angle 1 is 65 degrees, then angle 5 is also 65 degrees. Let's find the measure of angle 6. So in terms of angle 1, do angle 1 and angle 6 have a specific relationship to each other? Well, they're not corresponding, they're not alternate interior, they're not alternate exterior, so they don't really have a relationship. But we could say that angle 2 and angle 6, angle 2 and angle 6, those angles are corresponding. So that means that they're congruent. So if angle 2 is 115, then angle 6 must also be 115. And we're noticing a pattern. All of the angle values that we see here are either going to be 65 or 115 because they're all either congruent or supplementary to that original angle, which was measure of angle 1, 65. How about the measure of angle 7? Let's look at angle 7 in terms of angle 1. They're on opposite sides of the transversal. Angle 1 is on the left and angle 7 is on the right. And they're on the exterior of the parallel lines. So that means they are alternate exterior angles. If we go back to our notes that we just took, alternate exterior angles are going to be congruent. So since angle 1 is 65 degrees, angle 7 also measures 65 degrees. And we can probably guess what our final angle measure of angle 8 is going to be. Notice the pattern we have here. All of these greens are 65, all of the reds are going to be 115. And let's just talk about angle 1 and the measure of angle 8. Let's talk about the relationship between those two angles. So angle 1 and angle 8. So I want to know, are they alternate exterior, alternate interior, consecutive, corresponding? What are they? Well, 1 and 8 are both on the same side of the transversal T. They're both on the left. So that means they're either corresponding or consecutive. Angle 1 is on the outside of the parallel line, it's above, and angle 8 is below the parallel line. So these are going to be considered consecutive exterior angles. Consecutive exterior angles are supplementary. So if angle 1 is 65, the measure of angle 8 must be 115. So there we go, exploring how we can find the measure of different angles given two parallel lines and a transversal and the angle relationships that are formed.